conversions for coating and PVD, CVD, and also thermal spraying. Okay, Assalamualaikum and good morning. All right, so I have shared the last presentation slide in eLearn. So it's all complete. Altogether is 11 lecture. Okay, so we continue on the conversion coating. So this conversion coating is actually to deposit a layer of either oxide or phosphate ataupun chromate. So it's basically it form one layer either by chemical, meaning that it doesn't have any power, same as electrolysis, or we can actually also use electrochemically also supply the power. So we have two concepts here. So it can also use the same concept of methods, either you immerse it or you spray it. It can be actually treated metal, for example, like galvanized steel, zinc, magnesium, and also aluminium. So we can actually have different kind of coating on the same material. For example, that we have galvanized the steel, we can also add another layer of phosphating or chromating to enhance the corrosion protection, and to also if let's say we want to do a process of painting, you can also do phosphating then followed by painting, so that you can have a limited electrochemical or corrosion happen on the painting, because we have another layer of phosphating. So this is a common reasons why you use conversion coating. Definitely, the first reason is a corrosion protection, and the second reason is for the second process of painting. For example, for the second process of painting, for example, here is the painting. So we do a phosphating and then followed by painting, and the third one is the wear resistant. And we also can actually permit a better hold of the lubricant, especially in the metal forming. So we can actually use conversion coating to promote the better surface finish. We also can increase electrical resistance of the surface, and also for decorative purpose, for the some appearance of the part. Okay, there are two type of conversion coating. One is chemical conversion. So this one is not involve any electrical power. So means that you are immersing in the bath of the solution, same as electrolysis coating. So this process is for phosphating and chromating. And the second process, if you read from the book, so sometimes they might be divide the process, but some of the book they combine. For my case, I combine. So means that chromating, phosphating are fall under conversion coating, but some of the book they only consider phosphate and chromating as a conversion coating. So it depends on the reference that you use. Okay. For this case, we combine. Phosphating is under chemical conversion coating, and the other one is anodizing. So this anodizing are using a concept of electrochemicals. They will be anode, and they will be cathode. So normally it's used for aluminium. Saya minta maaf ya, setakat saya tak berapa. Okay. So all right. So for chemical conversion, so we have phosphating. Yeah. So we are transferring the phosphate. We are actually forming a phosphate film on the base metal. Either use galvanized steel, or use steel without galvanizing, or you can also use zinc. So it depends on the phosphating film that you want to coat. Normally people will use zinc phosphate. So you are coating the steel with zinc phosphate. You can also coat the let's say as a material with iron phosphate, or you can also coat we can coat on either steel, we can also coat on aluminium as well as magnesium. So you can use iron phosphate, you can also use manganese phosphate. So it depends on the your application. Okay, so definitely you should have a salt that contains phosphate. So you will have accelerating agent, and you also have the acid. So this is actually example that you will coat zinc phosphate. So yeah, we use this chemical. So you have natrium phosphate, you also use hydrofluoric acid, you also use zinc nitrate. So zinc nitrate will become a source of zinc. And this one will become a source of phosphate. So the coating thickness is around 0.025 to 0.05. All right, so this is for phosphate coating. And we also have chromate coating, chromating or chromate coating. It can also use for so aluminium, for copper, magnesium, and zinc. So this is actually we transform it to chromatic. So we can actually put in some color to make a nice appearance. We can actually use a color. So same as phosphoting, dia guna chromic acid and also chromate salt. Dimasukkan dalam bus. We don't use any electrical power. We just combine all these solutions in one bath. So normally it will not done at room temperature. So they will do at a bit higher temperature. For example, like 60 degrees Celsius, or mostly up to 100 degrees Celsius. So you have this example of chromate coating. You can see you can use on the car wheel. You can also use on the screw. You can see the color are different. You can also use for the aluminum foil bowl. So you can see that they have been actually coated with the chromate. And this is example for phosphate coating. You has gear. You coat it with the phosphates. You also can coat piston and also your wash. All right, the second the second part is actually anodizing, which is still under chemical conversion coating. Okay, this is actually electrochemical. So it uses anode and cathode. So they will be a process whereby one become anode, another one become cathode. So in this case, it will be they will actually form a oxide stable layer on the surface of aluminium. So you can also use magnesium. The common one people are using in aluminium, and you can also use zinc, titanium, and other material. Sorry, what happened to me? Can you hear? Can you guys hear my voice? It keep slow and slow. Boleh dengar tak? Okay. All right. So the reason is actually mostly for the corrosion and also the aesthetic value for decorative corrosion. All right. So aluminium, there will be a solutions that contains hydrochloric acid, and the container, the tank will act as a cathode, and and the part that going to be coated, which is aluminium, will act as anode. So in the solution, we'll have the ion and cation, right? So in this case, we have hydrofluoric acid. So H plus become cation, and SO2 negative 4 become an ion. So definitely an ion akan gini-gini pergi kepada anode, sebab anode adalah positive, right? So negative will go to positive and positive will go to negative. So what happened here, SO2 negative 4, they will go to the anode, which is now is aluminium. So what happened? Because aluminium is really keen to keen to form oxide with oxygen. So what happened? So aluminium will attract the oxygen from the SO24. So it become aluminium oxide. So the sample will be form aluminium oxide on the pipe. So this is actually the process. So you can actually form aluminum oxide on your aluminum part. So this is some example. You can also put the color to make it become aesthetic value. So nampak macam menarik kan. Jadi ni contoh keychain. This is a bicycle rim. This is actually car rim. You can see variations of color. Okay, so we go to this method of another method we call as physical vapor deposition. So we are actually using this concept actually for the materials is actually convert to vapor phase, and this vapor phase akan condense, akan bila dia dah jadi vaporize, material tadi vaporize, so dia akan condense on the part that you're going to coat. So and then they will form a thin film on the part that going to be coated. So the coating material that we use either metals, alloys. Metals mean that pure metals. We can also use ceramic, and we also can use inorganic compound. So the substrate that we can also use metal and also glass and as well as plastic. So this is some of applications of PVD. So here is actually you punya cutting tool. It was coated with the titanium nitride, which is very hard, and we can actually sustain from the wear and tear of the cutting tool. So you can also deposit to form electrical connections on the integrated circuit. And this is another example. They are coating magnesium fluoride on the optic lens. So this is for the glasses. Okay, the process start as I mentioned before, there are synthesis of coating vapor. So when the coating vapor was heated, when the coating material was heated, so this will become a vapor, and the vapor will be transferred to your substrate. And then once the vapor condense on the substrate, so they will be solidified and forming a thin film. We can have three methods for vapor deposition, which is evaporation. We can also have sputtering and ion plating. So the first concept, which is vacuum evaporation. So you can see here, so this is the source, right? The source of your coating material. So yeah, you actually heated this by resistant heater, and this material will be evaporate, right? The vaporized atom will actually evaporate and condense on this substrate that you're going to be coat, and then after that they will form a layer on this thin layer on the substrate. And the second method is sputtering. So you have using very high plasma. So what happened here, this is the target metal that going to be coated on this substrate. So this target will be ejected by the higher plasma and the atom will be ejected out and actually ejected from this target material and will be deposited on the substrate. So this is the common concept. I will not go through detail because we have actually learned details in others subject. So this is just to show you that this is part of coating. And the last, and this not the last, but for this dia punya coating process for vapor, so we have another coating process we call as chemical deposition. So it's use the same concept of vapor, but in this case they are using a gas. So these gases will be entrapped in, or we can actually condense the gases in the a furnace. So we have a substrate, then we actually flow the gases that we want that material to be deposited on your sample. But you can also have others powder that can be seated beside the substrate. So when this powder also evaporate and actually combine with the gases, and the chemical decomposition of the gases will be deposited on the substrate. So they are using the same concept of vapor, but this one is chemical reaction between gases and also powder. But sometimes they only have a chemical reaction only decompositions of the gases. So can be either two. So they will normally do in the enclosed environment so that there will not be any oxidations from the outside. So once it be deposited, so definitely they will nucleate and grows, right? Same as PVD juga. Then when nucleation happen, I forgot to inform just now. So after that, there will be a growth of your material on the substrate and form a layer of coating. All right, so this is actually the setup for CVD. You can see here they are supplying the gases, but in this case, there is no powder that they use, so they will decomposition of gases and will be deposited on the substrate, and there will be nucleation process happen and growth of the coating on the substrate. Same goes to the PVD. Sama juga. So they will be deposited and nucleation and growth. Okay, this is some applications for CVD for integrated circuit. You can use for integrated circuit, optoelectrical, micro machines, fine powder, solar energy, solar cells, refractory coating for jet engines, turbine blades. So this is some of the application. So you can see here, this is actually a SEM. It's a cross section. This is actually using PVD to coat the a sample, and this one is using CVD. So you can see that both are coating titanium nitrate. All right, so this is the last coating process, which is thermal spray. So what is actually thermal spray? So there will be materials that will be heated until a molten state, right? So they will be accelerated by the gases, and the droplet of the atom will be adhered to the surface and forming we call as splat. And many splat are forming a layer of coating. So definitely in this case, they will need a process to clean the surface, to ensure that activation of surface and so on, so that the molten metal will be when the vaporized when they actually the accelerated by the gases, so they will be a atom of the molten will be splat on the surface. If let's say the surface is not cleaned properly, so it will not be adhered to the surface nicely. So we can use pure metals and also alloy. We can also use ceramic, and we also can use metallic compounds, ceramic composites, and also certain plastic which is can sustain high temperature. So the substrate as well, we can use also metal, ceramic, glass, and some plastic, and also woods and papers. All right, so this is the types of thermal spraying. We have flame spraying, we have arc spraying, we have plasma and high velocity or fuel spraying. So the difference are actually come from the source of heat. From the source of heat. First, same as welding. So sama juga macam welding, cuma source heat berbeza. All right, so this is applications of thermal spraying. So you can also do thermal spraying for rework purpose. For example, this is some of the areas that was one off. You can actually rework it, and you can also salvage some of the part that was on machine undersized. You can actually do a rework on that part. So beside rework, they can also use for the definitely to create a corrosion resistant, wear protection, and so on. So that's a common purpose of coating. But beside that, they also can do for a rework process. All right, so they can use combinations of either combustions or high velocity gas stream that was actually used as the source of heat. And the coating thickness for the thermal spray is quite thick. You can actually have in between 50 micron to up to millimeter. So they can actually bonding the substrate either undercuts or simple roughening. So this is actually for thermal spray. So this is the components that involved during the process of thermal spray. So we have energetic gas flow. So you should have appropriate gun. So we use that the gun to feeding or accelerating the heating process and directing the flow of thermal spray. Means that the source of heat must be direct to the um, substrate that you want to heat. And you also have a feedstock that actually feed the either in term of wire ataupun powder ataupun road. So all the coating materials that are going to feed will be actually accelerated by this heating. So they must have a proper gun so that it ensures that the heating process is actually directly towards the substrate nicely. Otherwise, you will actually go to the certain areas saja. So make sure that the areas of the accelerating tadi dia akan jadi macam pattern. So the pattern should be protrude to your sample. It's not like divert to the other angle. So you can also have auxiliary gas feed to accelerated automized molten metal. And you also have to control the atmosphere. So you have to have a oxidation free. Okay, so substrate. So definitely, if you use thermal spray, your substrate must not be degraded by heat. If let's say your substrate cannot sustain the heat, so it will be more melt together. So the purpose of coating dah tak betul dah. So maksudnya you must ensure that the heat that was supplied must be less than the temperature of your substrate. So the substrate is supposed to be roughened because to have some addition. So you can use abrasive blasting. This is the minimum roughness around 2.5. So for spray hardened steel, so this type of materials are difficult to be sprayed because of the appearance of the structure. So you can it's not cannot, but it's difficult. You have to modify the surface roughness. And the thin section, because thin section, if let's say if you do a heating process, so definitely senang warp, right? Dia senang warp ataupun dia distort. So thin section have to be also careful when you use this type of spray. So this is the step in thermal spray coating. So the first one definitely surface preparation, and the second one is generation of energetic gas flow, and the third one particle or wire or root cord injection. So you must have a feedstock, and the number 4.